Hey everyone, welcome to this video on solving basic logarithmic equations and evaluating logarithms. Woot woot! If you've never watched my videos before, you're going to want to pause and try the examples when prompted, and there are always free guided notes available at divideandconquermath.com. And before we get started, one thing I want to make sure you know how to do is to put things in logarithmic form. That's really the key to this lesson. So I have these two review questions on here for you. If you have no idea how to do this, I have videos on this, and I will drop a link to that in the description of this video. Otherwise, pause the video, hit play when you've got this. Okay, so if I want to put this expression into logarithmic form, this will be log base 3 of 125 equals 5. And then if I want to put this into exponential form, this will be 5 to the first equals 5. So this is really the key for this whole lesson, so that's why I'm reviewing this. And so with that in mind, we can now talk about how to actually solve one of these basic logarithmic equations. So I say that they're basic because you can really just use the definition of a logarithm to do this. In case you forgot the definition of a logarithm, I will remind you it's right here. So this is kind of the basic thing that you need to be able to do. And basically, we're looking at equations where you can just use this definition to solve them. So for instance, if I rewrite this now in exponential form, so let me just note that, then the way that this would look, this would be 3 to the third equals 2x plus 1. And once you see it like this now, it's like something that you probably know how to do. So 3 to the third is 27. And then I just solve for x as usual, so subtract off the 1. I get 26 equals 2x. I'll divide both sides by 2, and I get x equals 13. And so that would be the solution to that. So for all of these equations today, or in this video at least, you're just going to basically use this definition to kind of help you figure out how to do it. So for instance, here's another one. So notice now I've put the x actually where the base normally goes, but you're still going to do the same thing. So for instance, if I rewrite this in exponential form, this would be x to the fourth equals 16. And now you just think about how would you actually solve this? Well, then you could just take the fourth root of each side. And you don't know, so normally when you take this root, you would have to take plus or minus. But with logarithms, this always just has to be a positive number, so you don't even have to worry about that. So then what this would mean is that x equals just positive 2. So that's basically the idea. Like you're going to write this in exponential form, and then you just kind of figure out what do you have to do to finish the equation. Okay, so I have two more here for you if you just want to give this a try. So you can pause the video and then hit play when you're ready. So for this first one, so this is going to be 9 to the second equals x. So once you do that, then you're basically good to go, right? So this is just x equals 81. So that one's nice and straightforward. Now, for this other one, this is going to be a little bit more work. So this is going to say that 6 squared equals 2x plus 4. So that's 36 equals 2x plus 4. And then I can go ahead and subtract off the 4. So I get 32 equals 2x, divide both sides by 2, and I get x equals 16, and then we're good to go there. So that's kind of the idea behind solving equations, but we still have to talk about how to evaluate them. But before we do that, maybe you could consider liking my video or subscribing to my channel or sharing it with a friend. That super helps me out. I'm trying to grow this channel, so every little bit helps. Okay, so now let's talk about how to evaluate a log. So this is very, very similar to actually solving a log, so that's why I've put these two topics together. So what you're going to do actually is you can basically set it up as an equation. So what I mean is I'm going to rewrite this as log base 3 of 27. I'm just going to say that this equals x because that will kind of help me figure out then the rest of this structure that I kind of need to do this. So if I wrote this down in exponential form, this would be 3 to the x equals 27. And now you just have to think about what you know about some of your powers here. So 3 to the what equals 27. That's really what a log is getting at. 3 to the what equals this number, or this base to what exponent will equal this number. So you might be able to just think through this just by looking at it, but if you're not, this is a more explicit way to visualize this. And then you've really just got to start going through your powers here. So 3 to the first is 3, 3 squared is 9, 3 cubed is 27. So that's kind of the way that you can go through this. And when you're dealing with these kinds of equations, it's usually going to be like more basic exponents. You shouldn't really be too worried about like it's going to be some crazy decimal or something. So if we just try two more of these just to kind of walk you through a couple more. So if I want to have that visual aid, again, I could just set it equal to x, and then I can think about this as 5 to the x equals 1 over 25. So what exponent would I need to make this true? And again, now you're just thinking about powers. Now, this has become a fraction, so that tells me that I need a negative exponent. And then 25, so 5 squared will be 25. So that tells me then that this would have to be x equals -2. So that's kind of the way you can unravel that. Now, for log of 100, one thing to remember with this is what this means. So log of 100 just automatically means that you're dealing with a base 10 log. So if I wanted to rewrite this, I could write this as log base 10 of 100. So just note that anytime you see log, it's always going to mean base 10. And so then if you have to rewrite that for yourself, that's something you have to do on your own end. And once again, if I want to have that visual, I can just think about that as being equal to x. So 10 to the x equals 100. So what exponent would make that true? Well, 10 squared equals 100, so x must equal 2. And probably the most formal way to actually write these answers, maybe just instead of writing what x equals, you'd probably want to just write what you found x equals. So this would be like the last way that you'd maybe want to state this, or log of 100 equals 2. So that's a slightly more proper way to actually do this. But like I said, this is a good little hack if you're struggling with this topic. So if you want to give these a shot now, you can evaluate these 4 and then hit play when you're ready. Okay, so starting with this first one. So first of all, you just have to know that ln e means a natural log, which automatically means log base e. So this whole problem is referring to log base e of e, and if I want to use that hack where I say that this equals x, then I could rewrite this in exponential form as shown. So then my x would equal 1. So the technical final answer to this then would be that the natural log of e equals 1. This is also a property that I've discussed in some other videos. If you've seen it, you may or may not remember it, but that's actually also just a general property. When these two things are the same, this always equals 1. Okay, so for b, so once again, if I want to just use that little hack that I have of setting this equal to x, I can say that this is 3 to the x equals 1 over 27, and I can just think through what exponent would make the most sense for this. So once again, this is going to have to be a negative exponent. This will be x equals -3. So if I wanted to write out the technical, final, nice looking answer, this whole thing would equal -3. So now for the next two. So if I set this equal to x, so once again, let's kind of think through the details of this. This says that 25 to the x equals 5. Well, now you're going to have to be a little more careful with this. So really the square root of 25 equals 5. So the square root as an exponent would be x to the 1/2. So that would be the answer. So depending on whether or not your course has actually gone through rational exponents, maybe this is something you are not familiar with. But if you do want a review of this, once again, I will drop a link to a video on that in the description. And then for this last one, so we already talked about log, so we think about this as log base 10. So this would be log base 10 of 1 over 10. So what would I do if that's equal to x? So if I just want to visualize that, I would think about it like this. So x would have to equal -1. And once again, just to be like totally formal about this, you would want to say that this equals -1. You wouldn't want to say what x equals. And same thing here, right? This would be log base 25 of 5 would equal 1/2. So that's like the proper way to state your answer, but this is a totally fine way to get there to that. And so that covers everything that I have for this particular topic, so hopefully that was helpful to you. I have lots of other videos on logarithms and algebra and all sorts of stuff, so hopefully I'll see you in another video. Thanks for watching.